order to place the inserts in the right direction, we need some kind of foolproofing element. This is why we need some kind of slot. We have to some kind of slot we need to manufacture on the inserts. And similarly, in the housing also there will be a corresponding slot will be there. We can match it on the here. And this is why this is where the venting has been provided. Now I am extending the core pin can be, the core pin can stop here only. The purpose of the core pin is end here. But why we are extending here the core pin is that here the injection molding has been taken place. There will be deflection will happen. If we extend it, there will be support from the core also, and there will be support from the sleeve ejection also. So the pin won't ejection, the pin won't deflect based on the injection. So we can make a pin with little flat on the one side. So there will be a flat gap will be O2, O3 to O5. So the air will pass after injection. The air will be passed through that flatness. So here in the top of the insert, there will be a flat cut will be there. That cut is around O3 to O5. So it will be escape through the mold tools. If we not provide these kind of things and all is there will be entrapment, air entrapment will be there happening, and the top of molding there will be a burn mark will be coming. So to avoid this defect, to prevent this defect, we are using this kind of venting system. There is a lot of venting proposal is there. We can place the vent on here also. We can place it in the cross-sectional view. It will be like this. We can place the vent on here also will be there. But now this is the best. We are injecting on here, so the lost will be lost filling obviously take place here. So the venting usually provide on the lost filling region. And how the pot can be placed in the tool? There is certain we can't place the pot in the tool wherever we want. We can place the pot near to the screw bush area. Why we can't be able to place the pot in the far away from the screw bush? Well, the one thing is the material travel will be more, and the second thing, the space, the mold will be more. So if you reduce the mold size, the cost will be reduced, and the machining time will be reduced, and the shipment also will be reduced. So all the things we need to consider to place the pot. So placing the pot is a crucial role in the mold design. So this is the screw bush. If you see here, this is the screw bush. This is the screw after injection. It is showing here, and this is the submarine gate. From the screw bush to the insert, there will be a minimum 10 mm will be there. 10 mm required, and this is the center of the inserts to the center of the screw. If you maintain these things, and from and if you maintain here one, and from this pot edge to the insert around 45 mm required. 30 to 35 mm required enough, because there will be certain kind of matching area we need after the inserts. So if you maintain these things, we can achieve this one. And this is the what you see here is the cooling holes. Cooling hole is required for cool the mold, and there is certain kind of dia will be there, and dia 6 to 12 will be there. Dia 12 will be there, dia 14 will be there, and there is certain this will be 8 to 12 mm we can keep from the insert to the cooling edge. And this is the typical layout for the 8 cavity molds. This is the plan view. Here the center area will be the here it is a screw, And whatever you are seeing here, the guide pillars used for aligning the core and cavity, and the ejector plate. This is the moving of it. There will be a ejector pins assembling here. This is actuator. This will be assembled to the ejector back plate. This and this will be clamped together. From the ejector back plate, there will be a moving of plate and will be there. Hydraulic ram will be fixed into the ejector back plate, and the ejector back plate and the plate once this is the one of this is the one of in the injection molding. Uh, ejector plate, and the ejector guide bush will be there. This and all will be this. The purpose is to eject the parts. There is different kind of pins will be assembling to the here blade ejectors and strike pins. This is the water channel that I am last slide I told you. No, this will be in will be there on side and out will be there on side. Take the cross section. If you say W cross section, if you take the cross section here, I am taking the cross section through two cavity and the guide pillar. So it will be like this. The sleeve ejection. This is the sleeve ejection. If you see here, this is the sleeve ejection. This is the core pin. Always the guide pillar will be assembled on the fixed off only, and the screw bush will be assembling on the cavity back plate. This is the cavity back plate, ejector back plate and the ejector plate, and the support pillar. Support pillar is that this space has to be it's calculated based on the ejection stroke. There will be here there will. Okay. The support pillar size will be depends on based on the core projection. This is the step-by-step design for the what I am showing before. This is the basic step-by-step design for the plastic component, but there will be these will be very similar to all the mold tools. But necessarily this is not this is not only the step. It depends on the designer to designer, and the company to company. Each company having different kind of mold bases will be there. But the thing is, this is the before slides and all the basic criteria for designing the mold designs. Now I am quickly intro into the molding wizards. Or during the course, you can learn the things. What are the see, this is the molding wizard. These are the kind of tools you can create using. There will be a separate section will be there for mold in SolidWorks, and the planar surface, filled surface, knit surface, and this is kind of normal surface operation using the 3D component. And this is the draft analysis to know how much draft will be there for the each plastic component. And here you can see the undercut analysis, spotting line analysis. Spotting line, it will show the potting line, but it won't be much correct. It will be different to different pots. And this is the split line. The split line and scale. Scale is the shrinkage factor we can apply. This is the first step involved in the mold designing. For applying the shrinkage factor, we need to apply the scales and draft and move phase. This under the normal operation we are using in the draft and move phase under in the 3D any 3D software we are using these kind of things. And there will be a set of surface, potting surface, and the core. Core is nothing but we can split the sliders and the core pins under using by these operations. So there is a very few tools only is there, but now I am tell you how to split this component. Wait for a minute, I will come back. Yeah. Now I am. Now I will show you how to. Now I will going to start this part. How to make a DFM steady for this part. So this is a door handle bezel. For door handle bezel, for first, if we get the component, we need to do the drafting analysis. This is the first step to analyze the component. If you not did this one drafting analysis, you can mold the it can make a split on the part, but if there is any undercut is there, you can't know it. But for example, I will show you this one. I am setting here, it is a 0.5 degree minimum which we require. Whatever you are seeing here on the green side, this is the cavity. Whatever you are seeing here on the red side, this is the core. Whatever here you can see the where it is, this is the match. This is the potting surface. This is a shut-off surface we will usually call it, where there is a hole in the component. We can match the core and cavity. And whatever you are seeing here, this and all undercut. Whatever you are seeing here on this component, it is an undercut, and this also will be an undercut. So for making this undercut, we can use the sliders, side cores, and for making these, for forming this undercut, we can use the lifters. There is difference between the lifters and the side cores. When we will use sliders and when we will use lifters, lifter is there is any internal undercuts. If there is any internal undercuts in the component, for example, so this is the part. So this is my split line. This is my potting line here. This will be formed by cavity. This will be formed by core. So for making this undercut, I need to eject this part. For forming this undercut, we need some kind of lifters will be there. This is a complex design. While ejecting, the component also will get ejected. At a time, the plastic will also get this is the mold mechanism. There will be some kind of mechanism will be attached into the ejector back plate and the ejector plate. This will be turned like this direction it will be turned there. So for forming the for product designers have to be make sure that this has to be a certain amount of distance we need to keep that. The reason is the lifter there is some space recorded for the ejection of the lifters. This has to move some amount. This has to be moved. For example, this is the undercut of 3 mm is there. It has to be moved around 3 plus the 2 times of this one. So there will be 9 mm at least required for this part. There is some 3 mm will be there, and this 6 mm there will be a travel from here to here. So this is the external undercut. Sorry, this is an internal undercut. For external undercut, if there is a hole in this kind of part, for example, this is the hole. For forming this external undercut, we will use some kind of sliders. This will be actuated through the finger cam. The finger cam will be fixed into the cavity side, and the sliders will be moving once it is get separated from the cavity. The moving through the action of finger cam, and this will be in the moving off. So for ejecting this external undercut, the sliders will be forming. I will show you how the sliders and all. There is separate calculations and all is there that I will show you during the course. So so this is the things, and we need this. Here it is a 20 degree. You can see here. We need this area. If it is 0 degree, means there is not good for the mold designers. Why means there will be a core and cavity matching will be there. Here the potting surface will be like this. If you see here, the potting surface will be like this. So all the this is the matching area during the mold closing. The core and cavity is directly, the core is getting directly contact with the cavity. So that area we need minimum, that is I told you in the earlier slide, minimum 5 to 7 degree required for this kind of area. But here it is they given 20 degrees, so it's fine for this. So we can place the ejector pins over here, somewhere around 4 pins we can place it here, and here also we can place 2 pins. And this is the enough. I think 6 pins here, 4, and here. I think 2, 4, 6, and 7 pins is enough for ejecting these components. I am talking normal ejections. So this is the draft analysis we need to study, where the undercuts will be there, where the sliders spotting line will be there. I already splitted the component. After extraction, like this will be there in the core side. This is the basic split for the sliders. And one thing I am noticing here, for this part, if you eject, we need to modify the part. Here, if you see that there is some kind of gap is there between this strip and here. So we need to fill the plastic over here. We can't form this surface like this. So we need to fill the plastic up to this rib, from here to this level. Correspondingly, from actually here we need to form this kind of ribs. This kind of portion we need to form up to over to this level. Then only the sliders can, if it is like this, means we can't take the sliders. Otherwise, we need to cut the rib over here. Okay. We need to cut the rib up to this level. So then only the sliders can move over here. And this is the cavity one. and these kind of things and all, we need to check it before giving to the cam whether it is possible to mill or not. If it is not possible to mill, we need to make a inserts over here. So before giving to the cam these and all, we need to steady the core and cavities. I will show you the lifter how it will be. This is kind of for ejecting this part. We will place the lifter over here. We will place the lifter over here. It will be ejected through like this direction. Another part I will show you. This is a part of fan bezel. I will quickly apply the shrinkage. How I will going to do that things. Now I am going to split the pond. Just follow the steps. I am applied the shrinkage of 0.6%, and for scaling factor we need to divide it by 10 and divided by 100 plus 1 we need to do it. So I am applied the shrinkage. You can find the difference before and here, right? Now the plastic is getting enlarging, right? After molding it will becomes like this. So now I am going to select my tooling direction as I am taking this as my tooling direction. It will detect potting line. So this will be taking as my tooling direction. So for potting line is this is my potting line and potting surface. So this is a straight surface. I am not going to do the manual surface here. So I am using this wizard only. There is some kind of manual surface also is there. We can use the manual surface by using ruled surface, or there is a lot of surfacing option out there. Now this is the flat pot. If you have the 3D pot or a very stepped potting line, that time you have to use that kind of things. Because we can't able to use the default one. Since it is a flat pot, I am using this one. I am applying around 75 mm. Now I am applying the shut-off surface. Even the shut-off surface, we need to all the things make it as no fill. Here there is option called no fill. That means that it won't create the surface by default. We need to create the surface by manually. This is not a flat shut-off surface. This is a up and down will be there. So whenever there is up and down shut-off surface will be there, then time we need to create the manual surface. If you make it as a contact, then it is create the surface, but it won't be a smooth surface. It will be like zigzag surface. So that I am not preferring. I am make it as no fill options. So the core and cavity will get separate. There will be separate folder will be forming here. I am hiding the pot. This is the potting surface where you send, where the red surface is the core surface and the cavity surface. So how we will form these kind of internal surface? We need to create our own surface. We need to form this surface, then only we can extract the core and cavity. That surface it will be usually like, I already splitted this pot. Bit of time to create such surface. We have to create the shut-off surface something like this. So after creating the surface, after creating the splitting, we need to take the core and cavity. After that, we need to make a insert on here. This is the insert you have seen here is the insert. We need to whatever you are seeing in the violet color, it is an insert for the part. It will be clamped to here. This and all we can make it in a core pin. And for forming that undercut, for forming these two undercut, there is a two undercuts are there. This side we can take the there will be a slider actuation will be like this. Slider actuation will be like this for forming these undercuts on the fan bezel. You can I didn't show you the undercut where it is. So I am splitting the sliders. There is a slider parting line here between the two sliders. So these are from here to here we can take it up from the one sliders, and this one we can take it in the another sliders. So once we split the mold and split the inserts and the sliders and all, the 50% of the mold design will be completed. After that, and there will be the company wise, there will be a mold bases will be there. There will be standard parts will be there. Each company having the standard mold bases will be there. We can import from their library. There will be a design library will be there. We can assemble these inserts into that housings. So this will be a this is a major thing we need to take care. How the slider parting line will be there, how we need to make the slider in right directions. So these are the crucial stages involved in the mold designers. Once this is completed, almost all the things will be over by fast. So this is the crucial stage will be there. I will show you the 8 cavity mold quickly. So this is the 8 cavity mold. This is the screw bush, and this is the locating ring which I have shown above. The cavity insert, cavity plate. So this is the overall mold tools, which is followed by locating ring is aligning the tools into the molding machine, and this is the cavity, back plate, cavity, core back plate, and the ejector plate, ejector back plate, and this is the platen which is fixed into the molding machines. And here there will be a ram. It is clamped into the back plate, which is actually for actuating this ejector mechanism. This is the spacer block for traveling this one, providing and supporting this back plate also. Now I am tell you. So we are placing this part into the this kind of things. The distance between these two parts will minimum 10 to 15 mm we need to keep for need some matching area for the plastic part. So the gate, and this is the runner system, this is the gating system. The gate is not fully finished in this design, just made it runner also incomplete one. And we can, and these and all the holes what you seeing here for ejecting these runners. You can see the core inserts. Definitely these can't be manufactured in a single one. So we need to split this this is a primary insert. From the primary insert we need to split these kind of things, because we can't able to mill these kind of deep ribs and all. So we need to split another 8 inserts from the primary inserts. And there is no cooling. This is a improper, this is not completely finished mold design. There is a not made any cooling channels over here. Just for showing purpose, I am showing this one.